multiplying expressions, and this one is the cube root of 16 x to the third, y to the fifth, and z to the sixth.
Okay. I want to handle each one of these separate. Okay.
Okay.
Let's do the number first. What's the cube root of 16?
Would that be 2?
Well, the cube root of 8 is 2, so I could write 16 as 8 times 2, and then that allows me to pull the 8 out. So now I've got 2 cube root of 2. You see how I got to that step?
Yeah.
Okay. What's the cube root of x cubed?
The cube root of x cubed. I don't know.
X. Okay. In other words, there's another way to do these radicals that might make this problem a little easier.
Okay.
That is, if we write everything with a fractional exponent, cube root is the same as taking something to the 1/3 power. When you do it this way, you can merely apply the rules of exponents. So
Okay.
I still can pull a 2 out, leaving a 2 behind. In other words, I can get it to this point. And now, what do you do when you have double exponentiation? What do you do with the exponents?
You distribute.
You multiply them.
Okay.
Okay?
So you multiply everything times 1/3?
Yeah. In other words, here's the rules. If I have b to the x times b to the y, I'm going to add the exponents because I'm multiplying the bases.
Okay.
If I have b to the x divided by b to the y, I'm going to subtract the exponents. And when I have b to the x all raised to the y, which I call double exponentiation, I'm going to multiply the exponents. Notice that you're never doing to the exponents the same thing you're doing to the bases. In fact, it's always one level less. Addition is one level less than multiplication, subtraction is one level less than division, and multiplication is one level less than double exponentiation. Okay? So using those rules, now this problem gets pretty easy. 1/3 times x to the third is just x. So this problem now turns into this. I still have to take that one of those 2's to the 1/3. But now I've got a complete x that I can pull out, and I end up with y to the 5/3 z squared. Okay? So anything that's got an integer exponent, pull out in front. The 2x and the z squared. Everything else has cube root. So I can put it back in radical format. There's my 2, and there's my y to the, I can actually pull a y out also. Excuse me, I didn't see that. In other words, y to the 5/3 is y times y to the 2/3. So, do you see how I got from there to there?
Yes.
I know I explained it a little confusing, but in other words, we still have 2 to the 1/3 because we've got the cube root of 2.
Okay.
And we have, what this is y to the 2/3. In other words, we have the cube root of y squared, which is the same as y to the 2/3. So I took my y to the 5/3 and I split it up into y times y to the 2/3. And the y came out over there, and the y to the 2/3 was left under the radical sign. And then all of the z's came out as a z squared. Now you don't necessarily have to put it in fractional exponent, but figuring out what the cube root of x cubed is easier if it's in fractional exponents, because you can just multiply the exponents.
Okay.
Okay. And another way I could look at this is I could take this y to the 5th and I could change that into y cubed times y squared, and the y cubed is going to come out as a y, leaving behind y squared. And then that z to the 6th, when I take the cube root of that, that comes out as a z squared. Notice that z squared times z squared times z squared is z to the 6th.
Okay.
Okay? If you have another one like this, might be good to do another one just like this.
Let's see. There's one kind of similar.
Okay?
But it's cube root of 16 plus cube root of 54.
Plus 2 root 54 or cube root?
Cube root 54.
Okay.
No, there's no 2. It's just 6.
Okay. So the secret to this problem, we can't add cube root of 16, right?
Yes.
Like that. Have I written it correctly now?
Yes.
Okay. We cannot add cube root of 16 to cube root of 54. They're different creatures. Okay. We can multiply, but we can't add. So the only way I can add these two things is if I can get the same number under the radical sign. Well, we've already figured out that that is 2 cube root of 2. I got that by representing the 16 as 8 times 2. And then the cube root of 8 is 2. So the 2 comes out, leaving a 2 still under the cube root sign. With me?
Yes.
This, I'm going to separate the 54 into 27 times 2. And cube root of 27 is 3. And so this turns into 3 cube roots of 2. Now I can add them. I got 2 cube roots of 2 there, plus 3 cube roots of 2 is 5 cube roots of 2.
Okay.
So whenever you have different numbers in the radical sign and they're asking you to add them, know that you have to simplify that down so that you'll have the same number. In other words, you can't always see it right away, but if you start trying to simplify these, you realize quickly that, oh, I end up with cube root of 2 in both pieces.
Okay.
Okay. What else you got?
All right. It says solve the equation. Solve the equation and round your answers 3 decimal places.
Okay.
And it's x to the 4/3 minus 7 equals 3.
It's the first step. I want the last step to be x equals something. What's the first step?
Maybe to add the 7?
Yeah, usually you want to get rid of these stragglers that are being, whenever you have numbers being added or subtracted to an expression, well, you're trying to isolate the x, so let's get rid of everything else. So I'm going to add 7 to both sides, which gives me this. Now how do I get rid of the 4/3? What can I exponentiate both sides to so that I'll end up with x only?
Can't you take the cube root of both?
Well, how about if I take the 3/4 of both? See, now when I multiply these exponents, I end up with just x. The 4's cancel, the 3's cancel. And I end up with x equals 10 to the 3/4. So whenever you have an expression to a fractional exponent like this, if you double exponentiate it to the reciprocal, always turns into x to the 1.
Okay.
Now, do you know how to get that in your calculator?
Yes.
You can do it a couple ways. You can do,
I don't have my calculator with me, but I do know how to type it in.
yeah, you can do it this way. 10 to the 0.75 might be the quickest way to do it. You could also do it 10 raised to the parentheses 3/4. You could do it that way. You could even do 10 cubed and then take the 4th root of it.
Okay.
In other words, that's what these fractional exponents mean. The denominator is the root. The numerator is its exponential. In other words, this is the same as the 10 cubed and then take the 4th root of that whole thing, or take the 4th root of 10 first and then cube it. Say you have a problem like this. It's almost always, if you're doing this without a calculator, you always want to do the denominator first. Because
Okay.
cube root of 8 is 2. 2 squared is 4. I don't
Okay.
ever deal with a number bigger than 8. But if I squared 8 first, I'd have 64. Then I'd have to take the cube root of 64, which is a harder problem. I still get 4. But it's almost always going to be to your benefit to take the root first if it's a non-calculator problem. Over here, we were taking 10 to the 3/4 power. Well, that's not a perfect quartic, so I can't reduce that to an integer. It's going to end up being an irrational number, and that's why they said round it to 3 decimal places.
Okay.
Okay?
And then the other one is
Do here. If I said this to you, how would you solve for x?
I'd multiply both times 3/2.
Yeah, it's not multiplication. What you're doing is exponentiating,
Okay.
that which is different than multiplication. I'm not really multiplying both sides by 3/2. I'm exponentiating both sides to the 3/2 power. And then this reduces to just x, and whatever 12 to the 3/2 power is. Your calculator, again, could tell you that.
Yeah.
I should have made it 16, because then I can do that without a calculator. Because I can take the square root of 16, which is 4, and then I can cube 4 to get 64.
Okay.
All right. What else?
There's parentheses x plus 3, and then parentheses to the third equals -12.
Now, this has a straggler number also, but it's inside the parentheses, which are all being cubed. So I cannot, as a first step, subtract 3 from both sides. What is the good first step?
Probably, I don't know, could you,
Exponentiate both sides to what power?
1/3?
Yeah. Now the left, those cancel, so I'm left with just x plus 3 equals minus 12 to the 1/3 power. You're going to have to get that out of a calculator. And then I'm going to subtract 3 from both sides. So there's your answer. Now, let's just talk about this for a second. What's the cube root of minus 8?
Would it be minus 2?
Correct. What's the cube root of 8?
Positive 2.
Correct. Notice that when we're doing cube roots, we don't ever get plus or minus results. When you do the cube roots of negative numbers, you get a negative answer. When you do the cube root of positive numbers, you get a positive answer. So if you're taking the cube root, you can take cube roots of numbers from negative infinity to infinity. Whereas you can only take square roots of numbers 0 to infinity. And that actually applies to whether it's odd or even. All even roots you can only take of positive numbers, and you always get plus or minus answers. All odd roots, you're only going to get a plus answer or a minus answer, depending on what it is you're taking the root of.
Okay.
I might have time for one more if you can make it quick.
Okay, this is just simplifying using properties of exponents, and it's the quad root of 16 to the 3rd.
Okay, another way I can write that is 16 to the 3/4 power. And this works pretty good because I can take the 4th root of 16. What is it?
2.
So this is the same as 2 cubed, which is 8.
Okay.
Okay? So whenever you see a fractional exponent, always look to see, can you take the denominator root of that number? And usually you'll be able to. It's rare when you get a number like we had 10. In other words, they generally make these so that the root ends up being an integer, a small integer, in fact.
Okay.
It's rarely going to be a number other than 2, 3, or 4, to be honest. Anna, I'm going to have to cut short just because I have 30 that I got to get to.
All right.
Let's see. I think your mom requested that the 8 to 8:30 be made permanent. So next be at 8?
Yeah.
Okay. I'll talk to you then. And then a lot of times I'll have the 8:30 to 9 open, and if you need to go for an hour, I can do that. I won't be able to if somebody has scheduled that 8:30, like what happened today. My schedule got all messed up today. I had a cancellation, which is why I could actually seen you earlier than 8, but then somebody else came in and booked the 8:30. So.
Okay.
All right. Have a good week, and I'll talk to you next Tuesday at 8.
All right. Thank you.